Hello, Matt Davis here with more homework quiz help. This one comes from section 9.2. Let's jump in. According to the Nielsen Media Group, 9.12% of households with televisions tuned in to watch the season 7 finale of American Idol. The next season, a sample of 468 families with TVs showed that 39 of them watched the season 8 finale. A producer wants to determine if the true percentage of viewers was different in season 8. Calculate the p-value for the test. Round your answer using 4 decimal places. So this one I've got pulled up here specifically asks for the p-value, but when you're in active learning, you're running through a series of questions, starting off with setting up the null and alternative hypotheses, going on to making a decision and discussing that. So we're going to go through steps 1 through 5 together and discuss those as we run through. And we'll point out where we hit the p-value specifically, but we'll give help with other questions along the way. Before we jump in and start doing that, we're going to make some changes. So instead of 9.12%, we're going to do 8.88%. And then instead of having it be 39 TVs or 39 of the households, we're going to have it be 37 instead. All right, so with those changes, let's go ahead and start running through the steps. So the first one, step 1, would be to determine the null and the alternative hypotheses. And to do that, the first thing you want to think about is what setting are you in? Are you in mean land or are you in proportion land? And they're asking us to do a test on the true percentage here, so that shows that we're in proportion land. So we're going to have a P equals type of HO. We want to see if we're different in season 8 than season 7, so we want to refer back to season 7 where 0.088 was the proportion of people who had watched the season finale. We need to make sure we do convert that 8.88% that they gave us to decimal form when we're setting up our null and alternative hypotheses. And then when we do the alternative, we want to think about is it left-tailed, right-tailed, or two-tailed. Keyword there is they want to see if it was different in season 8, and different doesn't specify lower or greater, just different, so we're going to do a does not equal right there. All right, so there's step 1. We actually can't fully do step 2. That would be to state the significance level, and in this particular part on active learning, they don't mention what it is. So we'll just kind of discuss that when we get to step 5, but that would be what we would normally do for step 2. But we can jump into step 3 and 4 because those don't require alpha. So for step 3, we want to gather and weigh the evidence, and we do that by doing our test statistic. Always good to start off writing the formula, and in this case, we're dealing with proportions, so we need z equals p hat minus p0 divided by the square root of p0 times q0 all over n. So that's the formula we're going to need. So we have a few pieces we need to collect. P hat we don't have, so we'll have to figure that out. P0, Q0, and N are all floating around in here, so we'll just go ahead and label those as we go through. But let's start off with that P hat piece. P hat would be X over N, the number of successes in our sample. And they told us that we had 37 successes out of 468 families. So that's our X and our N there. So 37 for the X, 468 for the N. Do that division, round it to the standard 4 decimal places, and you will get 0.0791. All right, so once we have that, we can start jumping in and evaluating our test statistics. So continuing on with step 3, our z-score would be p hat, which we just calculated, 0.0791, minus the claimed value of p, which comes from HO, so right there. So that's going to be minus 0.888. Whoops. Let's start over on that guy. 0.888. And then when you go down to the denominator, we do need to make sure that we're realizing that it's not p hat q hat in the denominator, it's p0 q0. P0 comes from the claimed value, so that's this one right here. So we're going to have 0.0888, and then 1 minus that value we just wrote down. Q0 is 1 minus P0, so that would be 0.9112. And all of that divided by the sample size, which was 468. We'll go to the calculator, see what we get for that. All right, so let's see. Open parentheses, because we do need parentheses around our numerator, 0.0791 minus the claimed value, 0.0888, divided by square root of, make sure we're using the P0, so 0.0888 times 1 minus that, 0.9112, divided by the divided by the sample size, which is still in the square root. So make sure you don't end the parentheses till you get that n in the denominator. All right, so we get negative 0.7377026114. We just want 3 decimal places on our test statistic, so that'll be a negative 0.738 rounding up because of the 7 following the 7. All right, so let's mark that down. Test statistic is negative 0.738. Okay, so from there we can move on to step 4, which is our p-value. Our test statistic was a z-score, so we're going to draw a normal curve, standard normal curve to be specific. We'll put 0 in the middle to represent the claim value, and then we have our test statistic is negative 0.738. Because it's negative, that'll go on the left. Because we're doing a two-tailed test, and we know we're doing two-tailed because of that does not equal to in H1. Because we're doing a two-tailed test, we want the mirror image of the test statistic on as well. So we want the area to the left of our test statistic as part of the p-value, but we also want the area to the right to its mirror image. And those, because it is a mirror image, those two sides are going to be the same. So when we go to do the p-value, you can pick either side. It doesn't really matter. But then you want to double the area that you get there. So I'm going to say the p-value is 2 times normal CDF, and I'm using normal CDF because it was a z-score, not a t-score, from 0.738 to infinity. Again, you could do the area on the left and double it, or the area on the right. It doesn't matter because they're the same size. So let's go get that on the calculator. By the way, the p-value isn't really just that area on one side. It's the two areas together. That's why I'm doing the 2 times right there. All right, so let's go to the calculator and calculate that p-value. So we want 2 times, and we'll go into the distribution menu. We want normal CDF. We want to go from our z-score, or in this case, the positive side version of our z-score, to infinity. All right, so with doubling there, we get 0.4605 followed by a 1, so we'll stick with the 4 decimal places on p-values. 0.4605. Let's go write that down. .4605. That's our p-value. That was actually the thing they asked us to find on the version of the problem that I have here. So we'll box that. That's what would go into active learning for your p-value. But in the previous problem, we wanted the test statistic. That would have been this piece. Problem before that was probably setting up HO and H1, so we have that up top. The problem afterwards most likely would be making a decision, and that decision requires us to know alpha, but alpha is generally either 1%, 5%, or 10%, and our p-value is bigger than any of those standard versions of alpha. So assuming alpha is a standard one, our p-value would be bigger than alpha, which means if we decided to reject HO on this particular problem, we'd be taking too much of a risk of making a type 1 error. So we're going to avoid that risk of a type 1 error by going with the conclusion, do not reject HO. Again, that does specifically require an alpha, so this would be the wrong decision if alpha happened to be 50%, because then our p-value wouldn't be bigger than that. But again, standard alphas are 1%, 5%, or 10%, and this particular p-value is bigger than any of those. All right, let's think about real quick where some of the spots are that this goes wrong for people. Got to remember when you go to the calculator, put parentheses around the top. You should get an open parenthesis from your calculator when you start the square root in the bottom. Make sure you don't close that till you get all 3 numbers in there. make sure that in the denominator you're not using p hat, but p0. And when you do 1 minus, don't do 1 minus p hat, do 1 minus p0. So this number right here is one where people often make a mistake too. So be careful with that. And then make sure you remember to double the area because it is a two-tailed test, and we know it's a two-tailed test because of that does not equal 2 in H1. All right, I hope somewhere in there you saw the spot where things went wrong for you and that you're ready to tackle this now. So head back to the quiz and good luck to you as you do.